So the extrude function in Maya has a few aspects to it, so let's just cover these one by one. The most simplest is the simple extrude, which we can do here. Just press extrude and then move the gizmo up to pull that geometry out, and then we can see there it's created some extra geometry around those faces to just keep the whole mesh connected, as is the nature of just a basic extrude. We're actually also set to keep faces together, so what this means is we can see there that all those faces are connected. In Blender, what we can do is the same kind of thing. We've actually got in the tool palette here, this tool shelf, we can go extrude region, and then that will allow us to pull out the faces there in the same manner. It's also extruded the region, which is essentially the same sense as keeping the faces together. So let's just undo that. In Maya, we can also take that checkbox off and then do a similar move. Let's just extrude again. Move the gizmo up, but this time we'll notice that it hasn't tried to preserve the relationships of the nature of these two faces sat next to each other. What it's done instead is created this extra geometry in between, which obviously you're not going to want in some circumstances, but you are in others, so it's very handy having those features there. Let's just undo a few times. In Blender, the way you would do this is simply just extrude individual. That's the same idea there. So if we just extrude individual and we move up, we can see if we grab one of these faces that it isn't connected to the other one in exactly the same way. So if we can undo that there. There is a simpler way to do this. We've got the E key just to do a simple extrude by region, and we've also got the Alt E shortcut key, which will give us a little shortcut menu here to with both options. So we can see those there. Another feature of within the extrude is essentially an offset or an inset. If we just grab these faces as well, check that keep faces together on, press the extrude tool, and then this offset here, we can now offset that geometry, which is essentially kind of insetting those faces. We can also note that in Maya 2013, it does it perfectly. It preserves the correct, what you might expect it to do, whereas it used to smooth off the geometry around the corners, and which would need fixing, but that's all sorted now. In Blender, how we would do this is essentially grab that those similar faces to the cube and just press I to inset, and I've actually got the tool set to outset at the moment, but if we just check this box here, we can see we've now moved to an inset, and then we can switch the exactly how much we want to inset there. So that's all fairly straightforward. Let's just undo that. There's also ways to find these in this menu here. I think it's in the faces menu. Here we go, inset faces, and it's the shortcut key I, as mentioned. In Blender, in Maya, the final thing that's worth noting is that there's actually an extrude along a curve. If we actually look at the options here, we can see the bottom half of this menu, the option box, is to do with curves. What we can do in Blender for this is invoke another add-on. So let's just bring up the user preferences. We can type in curve, and we can see here there's a mesh extrude along curve, and just check that box on there. And what that will mean is that when you have a face selected, what we can do is we can go and hit the space bar and type in extrude, and then we'll quickly find the tool. We can see there at the bottom, extrude along curve. There's actually a curve in the scene, which we can see here, this Bezier curve. And we can select, if there's multiple curves, we can select which one we want there, and change the resolution, and again the rotation, and the scale of it. We can just sort of slide that up there to see what effect that's having. So those are the basic equivalents of the extrude functions in Maya shown in Blender. Bridge is quite a straightforward tool. We can just highlight a couple of edges and then click bridge, and then we get a face that bridges the gap between those two edges. There's also a few other tools, options in here, which would allow us to change the amount of divisions, for example. So we can do that, which is quite straightforward. In Blender, what we can do is we can do kind of the same thing here. Let's just grab these edges, and then what we can do is we can press F to make the edge or face, as we've got here, and that's just created one large face there in the middle. We could also do mesh and then edges and then bridge to edge loops, and that will essentially create those edges there, but we would then need to dictate how many edges we want along there. There's also more ways of doing this, but we'll just leave it there for now. We'll cover some more detailed edge looping a little bit later on. There's also in Maya the append to polygon tool, which if we just access it now, we can click on one edge and then it'll show us all the other edges that we can then try to attach the face to. So now we can just press enter, and we've just attached one face to another. In Blender, what we would do here is essentially the same thing, because really we're just highlighting that edge and then press F, and then it's just going to fill in between those edges. So now we can do the same thing here to create a triangle face, just F to fill. This is, if we just bring up our Control E for edges menu, we can see make edge face is at the very top there. A fairly new tool in Maya is the project curve on mesh and the split mesh with projected curve tools. These sort of work hand in hand really. What we can do is I've got just a quickly subdivided plane there with a curve hovering above it. What we can do is we can just highlight these two objects and then project curve on mesh, and then what we get is this sort of purple outline there as to where it is projected. We can even start to select the original curve and move this around. What we can do is then hit the split mesh with projected curve, which we need to highlight everything first. Split mesh with projected curve, and then what's happened now, if I hide everything else and then switch into vertex mode, you can see along where that curve was, it's actually divided the geometry. And it's really just as simple as that really. In Blender there's no direct equivalent, however I'm going to try and kind of do this. It's not as neat or as tidy, but let's just see what we can do. I've got this plane here, it's a standard plane, and we've got this Bezier curve here. The first thing we need to do is just we'll convert this Bezier curve to a mesh object. So let's just do that, a mesh from curve. That was a menu brought up with the Alt-C shortcut. And let's tab into this now, see the density of the mesh. So we've got these handful of vertices there. What we need to do now is to project it onto the surface of this plane. For that, what we can do is we can switch our snapping element type to face, and if we just tab into it and highlight all the vertices, what we can do then is hold down G to enter the grab or the move tool, and then just press Control, and that will initiate the snapping, and then just press the left mouse button to just confirm that while the Control is still held, and that will snap it down to the face, as we can see there. What we can do then is to join these two objects together with shift select them both and then go Control J. Now at this point what we can do is tab into the edit mode, and as you can see there we've kind of almost got the idea, but it's not really quite as neat. Because it's just these edges here are just hovering on top of the face, so they're not actually welded in or anything. What we can do is, this is going to completely destroy the face really, but if we just delete only the face, we're left with now just edges, and these side edges, we can't have them either. We're going to have to get rid to delete those edges. And now what we can do is we can go into vertex mode, highlight all the, I'm just going to go to the top view just to make the selection a little bit cleaner, and then just grab those vertices there and press F to fill that face, and then do that again. I'm going to press B for border select, select these, and then press F again. Oops, I'm going to actually deselect the original selection though. Press B for border select, grab those vertices, press F to fill that face. I'm actually then going to switch back to vertex snapping type, just to clean up the sides here, because we need to align these outside vertices to where the four corner vertices of the original plane were. So I'm going to press G. After I press G, I'm actually going to constrain it along the X axis using the middle mouse button to select that, or you could just press X. And then I'm just going to Control and then highlight this, left click this vertex down here to align it to that. Same here, just in case that was slightly unclear, apologize. Let's just select this vertex here, press G. I'm going to choose to press X this time just to constrain it along that axis, and then hold down Control to initialize the snapping method, and then just select that vertex down there, and now they're nicely aligned. What we can do now is just select those outside vertices and then just delete them with the X key, and there you go, we've done. So that was not really the same as the Maya projection curve and split, but that's a bit of a hack as we would do there. Not massively useful because obviously you're not splitting along an existing face. If this had UVs we wanted to keep, or maybe there was other elements to this that we wanted to keep, not have to destroy the face to then rebuild it back again. But anyway, that's the best I can do anyway. So we'll just leave it there. The Cut Faces tool, we can just enter into the options here. There's several different ways that you can cut these faces. I'm just going to concentrate on the most interactive version, which is this interactive here. Let's just enter the Cut tool and close the window. What we can do is we can just left click and drag, and we get this line here that we can rotate around, and once we let go, it's just going to score in some edges into the mesh, in fact all the way around the mesh, along that line that we had drawn. If we just look at this in vertex mode, we can see that it's just created all those vertices. In Blender, we can do the same kind of idea. We just press A to highlight the mesh if it isn't highlighted already, and then press Shift K to enter the knife tool, and then left click on the other side, and then press Enter, and then if we just look around the mesh, we can see we've got the equivalent kind of idea. Let's just undo that. It's worth noting that there is a K tool rather than just a Shift K tool. So if I just press K as a shortcut instead of the Shift K, we can do the same kind of idea. Press Enter, but this time it won't go all the way around the mesh. Instead, it will just be restricted to the view, the faces that the camera can view at the time that you do the tool. So that's just worth noting. I'd just like to have a look at this interactive split tool as well. Maya used to have a split polygon tool. This was pretty good, but it did have certain limitations. This interactive split tool seems to have done away with all those limitations, and it's fully featured now. What we can do, the options here can show up in this tool settings here. What we can do is we can left click. I'm just going to left click and drag just to slide it along the nearest edge, and then let go, and then left click this edge and then slide just to see exactly where we want to be. And now what we can do is we can left click and select the original edge that we started the cut on, and now press Enter, and the interactive split tool has no problem with that. This was one of the limitations that the split polygon would have it would not have liked that. It wouldn't have. It would have just cancelled the entire cut, which can be quite frustrating if you've done quite an elaborate cut and not quite realised you've gone back over an edge. In Blender, we can do the same kind of thing again using the knife tool. So we can just enter this with the K shortcut key, and we get the similar snapping along edges and things. So if we just left click there. Left click there, left click there, and then press Enter, we can see we get the same kind of idea. What I'd just like to do is just one more thing, is press the K key, left click there. Now what we can do is we can hold down C to constrain it, and now you can see that we're getting a kind of 45-degree constrain, depending on where we are there. We have to press C and hold let go, by the way. I was foolishly holding it down, but anyway, we can just now select there, press left click there, and then press Enter, and now we've got that those edges there. The Insert Edge Loop tool is pretty straightforward. It does exactly what it says on the tin. We can just click on the option there, and then we get a slightly different cursor, and then we could just click and drag on an edge to create an edge loop along that. And then we can place exactly where we want that edge loop. We can then also use this Offset Edge Loop tool, which will allow us then to click on the edge loop or any edge loop, which will then create 2 more edge loops that we can then sort of place exactly where we want them to be. This is kind of like gives us an option to sort of bevel that edge in a way, but still preserve the original edge. This can give us some pretty handy ways to get around some problems that you might get when you realize you need to add in extra geometry and you've got textured faces and you don't want to actually bevel the edge, because that would create new faces and possibly break the UVs. But in any case, we could then just delete that edge if we wanted, and we've essentially kind of done like a bevel there. Anyway, we'll come to that shortly. In Blender here, what we can do is simply select the Control R, and that will insert an edge loop wherever we actually, depending on which edge we actually choose. So we could just do that there, and then we can actually then slide it along, and then if we click one more time, left click one more time, it will actually place that edge loop in that position. There is no real offset edge feature, but perhaps somebody's going to be scripting that soon. In Maya, we have the Add Divisions tool, so we can select some faces and then subdivide it, but we can also subdivide it a different amount of times depending on which direction we want this to be. So let's say 5 directions in U, 5 times in U and twice in V. So we can see what this looks like here by clicking Apply. We can see we have 5 splits along in this direction now, and then across we've got the 2 splits in each face. In Blender, we don't really have that tool really. We just have the standard subdivide. So if we just select some of these faces, we can just press W and then subdivide, and that will do an even amount of subdivisions, and we could just crank that up or down like so. But we can't actually dictate that we want it to subdivide in more times in one direction than another. That's just the way it is at the moment. Perhaps that'll get added soon. Here we've got a cylinder which has been twisted at the top and with an extra edge loop around the center. What we can do here is, if I just use the transform gizmo to push this edge up and down, we can see how the edges that flow downwards through this edge loop are being sort of kinked quite heavily. What we can do is we can use the slide edge tool and now use the middle mouse button to essentially preserve the flow of the edge loops around this edge loop in the center, and then place it in a different area. In Blender, what we can do is we've got the same kind of idea here, another twisted cylinder. I have this edge loop selected in the center, and what we can do is we can invoke the Control E edges menu, and then down here we have edge slide, which then allows us to move the mouse up and down and do the same kind of thing, just left click to confirm that action. In Maya, if we want to make some simple moves, we can just grab this face, move it along the x-axis, and we can see that it doesn't create a node in the mesh history here in the channel box. If we did want it to do that, we could use transform component, which creates this poly move face too. So we can grab that and then actually make a change, say maybe rotate this on the local Z, and we can see that that face is now starting to rotate. All this information is essentially the same. This might look familiar because it's essentially the extrude information that you would get, only instead of the, let's just have a look at the extrude here, we get these 6 additional options here at the bottom to do, specifically to do with extrude, which we obviously don't need when we're just moving. This, by the way, could have been just a move vertex or move edge. It will all do roughly the same thing. In Blender, we don't actually have a channel box with the mesh history stacking up nodally like it does in Maya. So, but when we do make a simple change, like so if I just move this over here, it is essentially recorded in this toolbox over here, where we can then start to manipulate that action after we've performed it. But if we go ahead and do another action, it will essentially overwrite it. But we have got plenty of options here that we can, at least if we remember to do this straight away, or we don't see there being a need to actually keep this information, then it shouldn't be too much of a problem. But we can still edit this just at this stage. But as I say, as soon as we Blender doesn't actually work in a mesh history, construction history sort of a sense, in that you can manipulate and edit operations that you performed a few steps ago. So there isn't really a direct equivalent in that sense. Here we have a few triangle edge related tools that we can use. In Maya we've got flip triangle edge, which is essentially if you have just a simple square polygon here and you want to flip the triangle in there, you can. If you try to do that here, it won't work because it requires that sort of geometry. Here, if we use the spin edge forwards and backwards, we can sort of move it around. Really, this is helpful. I mean, these tools kind of duplicate each other in a sense, but if we move over to Blender, the equivalents, we just simply have the spinning of the edge. So if we actually just take a look at this first, we have the Control E edge menu, and we have rotate edge, clockwise or counterclockwise. So let's just try that, and then just Shift R to repeat that command. We can see we're flipping that round there. Same here, essentially, if we just grab this edge and do the same thing, Control E, rotate edge, it's essentially flipping the triangle edge in that way there. So that's the basic equivalent there. The poke face tool is quite simple to see what it does. We can just poke that face there. All we've got is a vertex now in the center of the selected face. In Blender, there is no direct equivalent of this, but I don't suppose it would be too difficult for somebody to just do a quick script that essentially recreated that. In the meantime, though, what we can just do is highlight a couple of vertices, press J to connect them. Let's grab that edge and then subdivide it. And now grab the vertices that now come through here, and now press J to connect those up, and that's essentially the same idea. So not exactly the same, a few more clicks there, but as I say, hopefully if there's enough people shouting out for it, or somebody wants it, then it probably won't be too tricky to code. Okay, the Wedge Face tool. What this will do is it will take a selection of faces and then rotate them around some selected edges, a set amount. So let's take a look at the options. We've got 90 degrees and 4 divisions we can expect to see here in a second. So let's just highlight a couple of edges for which to use as a kind of pivot point, and then click Wedge Face. And then we can see we've actually extruded out 4 divisions at 90 degrees based around this point here that we've got that we selected the edges at. So let's just undo that. In Blender we can do the same kind of idea. Just got this cube here. What's going to happen is it's going to use this 3D cursor here, and it will use that as its pivot point. This tool is called Spin in Blender, as we can see there. Now that doesn't look exactly right, as you can tell, but let's say let's just do 4 steps. That's a little bit closer to what we've just been looking at, and we can see down here we've got an axis which isn't quite right. So let's just round this off to, that's the 1, this to 0, and this to 0. And now we can see that's a little bit, well, that's perfect now. The problem is what we'll get is a load of extra geometry that we probably don't want around here. So if I just hit Z to enter wireframe mode, and then border select all the vertices here, select In fact, I'm going to just B and middle click these just to deselect them. And we can see at the top there, we've got 10 verts selected out of a possible 24. So we've got a lot of duplicated geometry at these points. So all we need to do is just remove doubles. And then we can see at the top there, it's removed 8 vertices. And now that we have just 2 vertices selected out of possible 16. So that's the equivalent there of the straight ahead wedge. There's just something about this wedge tool which is worth noting really, is that what you can do is we can grab, it's quite handy for creating pipes, you know, that are kind of going around edges and so on, going around the walls 90 degrees, and you don't really want them to sort of bunch up right at this this point here. It doesn't look very realistic. You want it to be like a curved bend rather than it just being completely jutted. So what we can do is we can actually just delete that geometry there, but we can do the same thing again. So we're essentially doing the same thing, but we're kind of going to cheat it slightly, and we're going to have those edges selected instead. See, the reason for this is because the wedge needs to operate on some, the edges that you select must be part of the faces that you also select, which is why we've created these phantom faces here, because we need the pivot point to be much further out in this distance. What we can do now then is click wedge, and it's going the wrong way. Let's just go into the channel box of the wedge face, and instead of it going 90 degrees, I'm just going to turn that to -90. If we just grab this geometry now, because we don't need it, just delete that. You can see that's a much more pleasing and probably much more realistic sort of pipe arch that you might get sort of going around various bends and whatnot. In Blender, we can kind of do the same thing. If we just kind of duplicate that again, just highlight that face, and then just go wedge, sorry, not wedge, obviously that was the Maya, just spin, and then just resolve this again, 1, 0, 0. What we can do is we can actually change the center here. So let's pull it out along the Y here a little bit more, and then we can see that that happens there. Maybe give it a few more divisions. So yeah, hopefully that's kind of shows that we can do essentially the same thing there. It's just based on this center point here that we can key in a specific value for example, until you get what you're looking for. Next, we've got duplicate face. This couldn't be simpler really. I've not got the separate duplicated faces option checked though, and I have no offset on it, but let's just apply that, and all we do is we can move out of the way, and we can see we've essentially just duplicated a face. Very straightforward stuff. In Blender, if we wanted to do this, we could just grab this face here and just go Shift D, and now we can just move it out of the way, and it's as simple as that. Connect components. There's two things about this that I'd like to point out. We can highlight these 2 vertices here that we have, and then just connect components, and it will connect them with an edge. And that's quite straightforward. Another thing we can do with the connect is highlight a few edges. Let's just try and grab that, that, and that, and then go connect components, and it connects those components in that sense. What we can do with Blender is we can grab, again, similar kind of thing, that vertex and that vertex, and what we can do is go Control V, and we have vertex connect there. This will do what we need, or the shortcut key is J, and there we have it. We could just keep on going with, if we just undo that, I could highlight that vertex as well and do the same thing, J, and it will cross through there. To do the other type of connect, it's not a vertex connect. However, what we can just do here is a simple subdivide. So I've grabbed those edges, go W and subdivide, and that will essentially connect those edges together.
Detach component within Maya is basically the opposite of connect component. If we just draw in a cube here and delete the faces we don't need, and then highlight an edge that we want to detach, basically it's just going to detach those two faces that were in the middle of those edges there by generating an extra bit of geometry for us, just this extra edge and the extra two vertices for it. And then we can just do the same by highlighting a vertex, and then what that will do is just create two extra vertices and edges, but at the where those edges meet, what we didn't have selected, will still be just the one vertex there and still combined, still connected. In Blender this is achieved with the Rip tool for a single vertex and the Edge Split tool for edges. So let's take a look at the Edge Split tool first. We can just highlight an edge as we have here, a similar edge as we saw in Maya, and then go to Control E and then Edge Split, and then we can see that we get the same kind of result. So if I just select one of the edges there and just move it, you can see it's essentially just detached it. For a single vertex we need to select it and then press V for Rip and then left click without moving, and we have the same result as we saw earlier. So if I just select that vertex and then press V, you can see now if I left click, we can now press G to just move that out of the way. And then we can see over here, if I just press Z and then border select that area, we can definitely see that that's just still the single vertex. I'd just like to give a bit more attention to this Rip tool though, as there's a few more things we can do with it. First of all, I'd like to point out that a vertex where many edges meet, the location of the mouse cursor at the time of pressing V will tell Blender which faces to rip. So for example, if we just come over to this piece of geometry now and just highlight this central vertex, so that means that if we press V over here, we can see that we're ripping this face, these edges away. Now if we just come and hover the cursor over in this direction instead and press V, we can see we've ripped those faces instead. So similarly, if I actually go V, select that vertex and press V here, we can see we've ripped those edges away there. So hopefully that kind of makes sense. The one other thing that I'd just like to point out is there's also a Rip Fill option. So with the Alt-V key, we can actually create geometry in the gap that would have been created with the regular rip, which is a handy time saver in certain circumstances. So if we just go again and press Alt-V, we can see we've created this extra geometry there now. And then again over here, maybe we can grab that one and press Alt-V there. You can see that we're bringing that extra bit of geometry in there. And that's it really. So that's a brief look at the Detach Component tool and its Rip and Edge Split counterparts in Blender. Further down in the Edit Mesh menu, we've got the merging options. We can grab a vertex, snap it into the same position as another, and now we can merge them into one based on a distance threshold that we can see. In this instance, as the vertices are right on top of one another, the threshold isn't really going to make that much difference though. But the larger the threshold, the larger the distance between vertices can be while still merging them together. We can also merge to center, which is very straightforward, merging to the center point between the selected geometry. Collapsing an edge will do a very similar job as the merge to center if only one edge is selected. However, it's more suited to selecting an entire edge ring, which can then be collapsed. The Merge Vertex tool will allow us to select vertices and then select the next vertex to merge into, so similar to the first operation we did, but perhaps just a little faster. And then we can also merge edges, or faces for that matter, so we can just select a couple of edges and then just try to merge those. So let's just take a look at our options in Blender. Most of our merging options can be found with the Alt-M shortcut key. So if I just press Alt-M, we can see with edges selected, we've got these three options here. We can go at center, which is similar to as we saw before. We've got the at cursor, which is going to take it to the position of the cursor. And we've also got a collapse option, which, as I say, is perhaps better demonstrated with a ring of edges selected. So if we just go like that, we can see what's happening there. And then if we go switch to vertex mode and then select a couple of vertices, we can see we get an extra couple of options. We've got at first and at last. So if we select at first, that will move the position of the last vertex selected to the position of the first vertex selected, or the opposite. So if we just go, say we want to move that one to that one, we can go first to last. So we want to go to last, and then we can see that that's happened there. So if we just press Z to toggle into wireframe, B to border select that, we can see it's definitely just the single vertex, as we can see in the header of our info window. So just undo that though. So that's the basics of the merging options that we have in the Alt-M menu, but that doesn't really address the initial issue that we had where we've moved geometry on top of other geometry. So for example, this vertex here, let's press G and then hold down Control to get into our snapping mode, and then just left click onto that vertex. This, by the way, this is because I'm switched from incremental is usually on by default, but I've switched this to vertex, so we can just do that again. We can go G and then hold down Control and then just point to that vertex there, left click, and then we can see we should have 3 vertices in that space. If I just border select that, we can see that we're actually only getting 2. This is just because we've got this limit selection to visible on, but if we just wireframe, we no longer get that option down there because it's insignificant at this stage because it's just going to select everything. But we can see that's definitely 3 vertices. And now if we press W, we've got access to our merging options down here as well, but we've also got access to the remove doubles. We can see this in the tool shelf as well, merge and remove doubles. But if we just go W and then remove doubles, we can see that we've now removed 2 vertices. And now if I border select here again, if we just do that again, just press B, we can see we've just got the single vertex. So if I just undo that a couple of times though and just repeat, just grab those and then remove doubles, we can see although we've removed these 2 vertices, we've also got our merge distance down here, which we can just turn. This doesn't need to be very high at all. This can be almost 0. In fact, let's just give that a go. If we 0 that, it still works from the looks of it. Yeah, we've still got the single vertex there. So that can be set very, very low when the geometry is right on top of each other. But if you want to start to merge these together, for example, we can go remove doubles and then just turn this right up to 10. So that should be Blender units. We can see that it's basically merged everybody together there. So that's just the equivalence that we can see there from those various different merging tools that we saw in Maya. Let's take a look at the Delete Edge Vertex tool. So when selecting some edges and then pressing the backspace to delete, the edges will be deleted, but the vertices that made up those edges will remain. For a cleaner, more complete delete, what we'll need to use is simply the Delete Edge Vertex tool, and this will take the vertices along with it. So we can do the same kind of idea in Blender under a single tool, which is found under a single hotkey. Here we have the monkey head here, and if I just press X, we can see we get our delete menu, and we've got dissolve here. So if I just select that, we can see that the same sort of issue has happened as we saw when pressing the backspace in Maya. You can see that these edges have obviously still got their vertices selected. Now we could just switch to vertex mode and then dissolve these, which is fair enough, but the actual tool does enable us to be able to take it all in one go. So if we just do that again, X, dissolve, and then if we come down here, we can see we've got an option to just simply dissolve the verts. And then when we select that on, that is now the standard for that tool right now. So if we just grab this edge loop here, press X and then dissolve, we can see that it has taken the verts with us automatically now because it's remembered the setting that we've set for the dissolve function. So if we just undo that a couple of times, we've also got another type of dissolve that I just wanted to point out, which can be found here under the dissolve menu. So if I just go limited dissolve, we can see that not a lot has actually happened there, but if we just start to move this up, we can start to see we're actually basically dissolving, and it's taking the verts with it along with it, by the way, but it's doing it kind of by angle. So we might be able to get some very, very specific automated results that we might be looking for there. Just to really drill this message home, this is simply a plane that has been subdivided down the center and then just rotated around the 3D cursor there, just 35 degrees. So if I just grab that one edge and then just go mesh, dissolve, and then limited dissolve, we can see it's set quite high so that it's deleted that edge. But if we set that down to 5, we can see that it hasn't. In fact, if we just keep on bringing this up, and then just as we get to 35, that's when it's deleted it, as that is the angle for that edge. So that's basically another alternative method of being able to delete, but that's the essential equivalent of the Delete Edge Vertex tool in Maya and its Blender equivalent. Chamfer Vertex and the Bevel tool are both very straightforward tools. We can select a vertex and then just press chamfer, and then we get a chamfer, which is just a flat surface plane where the vertex was. And then we can also alter the amount of chamfer if we want afterwards. To bevel, we simply select an edge and then click bevel, and then we can change the bevel amount with the offset value. But there's also plenty of other settings that we can use to tweak the bevel. One of the key attributes is the amount of segments that's created, so we can turn that up to say 3, for example. In Blender, these functions can be found within the same bevel tool. The shortcut for an edge bevel is the Control-B shortcut key. So if we just go Control-B on this edge that we've got selected now, and then we can just move the mouse just to set the offset. And then we can also change the segments by using the scroll wheel. We can of course then refine the settings further once we've left clicked to confirm. Just in the toolbox area down here we can see that we've got segments and offset. You'll also see that we've got this vertex only option. This is basically our vertex chamfer option. So if we just come over to here, I'm just going to select this vertex because we can actually just use a slightly different shortcut key just to jump straight to that chamfer vertex, which is Control-Shift-B. And then so if we just go Control-Shift-B, we can then set that with the cursor, just exactly how much we want to set that offset amount to be. And then we've also got these the scroll wheel here as well, which will give us our amount of segments.
This area of the Edit Mesh menu is all to do with creasing. What this basically does is if we're press number 2 on the keyboard to enter a smooth mesh preview mode. We can see here that we see the frame of the cube, but we also see what that cube would look like with a few smoothed subdivision levels to it. And in this case, it more or less deforms it into a sphere. If we wanted to try and preserve more of the details of this cube, the general form of it, what we can do is we can highlight some of the edges there, enter the crease tool, and now middle mouse button to drag and increase the creasing values of those edges, which tries to, as we can see, preserve that the cube nature of the top of this what has now turned into a sphere. If we grab the bottom edges and try and increase their creasing value as well, we can see we're maintaining yet more and more of the original form of the cube. And then we can take it from there. In Blender, we have the same kind of idea. It's actually called creasing as well. What I'm going to do is just press Control-3 on this cube, and what that does is add us a subsurf modifier at a viewing level of 3 subdivision levels. I'm just going to crank that up a little bit more just to give it yet more smoothness to it. And then if I press Tab to enter into the edit mode and then grab some of these edges, let's just do a similar kind of selection as we had in Maya. Grab those there, and now what we can do is we can either go Control-E and then Edge Crease, which is the shortcut key Shift-E, and then what we can do then is move the we get these double arrows here which can increase the value, creasing value. We can also see in here in the properties sidebar that we get a mean crease there, so I can just crank that all the way up to 1. And then it completely preserves the sharp edges of that form of the cube while still subdividing the rest of it. To the other items in the menu, the Edit Mesh menu to do with creasing is more or less to do with just removing this detail. So what we can do is we can just press A to highlight all the edges and then just type in a 0, and that will essentially clear out all the creased edges there. Finally, in the Edit Mesh menu, we have Assign Invisible Faces. What we can do with this is simply select a face. Let's have a look at the options. We can assign or unassign. So in this case, let's assign because we don't have any requirement to unassign anything yet. Click Apply, and then not a lot actually looks like it's happened in the viewport, of course, but this is because it's a render time only tool. So if we just render now, we can see the front face is in fact invisible, and we can see the back of the box. If we just switch that now and click unassign, apply, and then render that again, we can see the front face is back. If we go to Blender, there's no real direct equivalent of this, but we can kind of fake it. I'm actually just looking through a camera here at a standard cube. I've also switched on ambient occlusion by ticking this checkbox here, and just to make things a little bit easier to see. In fact, let's just give it a quick render. with F12. There's our box. And if we come to the materials panel, this in the properties window, we can select new here just to give it a new material. And what we can do is just say this is the base color. And if we actually add another material now, and then click new, and then call this invisible, what we can do is we can press tab and select the front face, and then assign it the invisible material. Obviously we haven't done anything to this material yet, so let's just make this appear invisible, which we need the transparency for. And then we could just slide alpha and specular down to 0. And now if we render, we can see the inside of the box. Obviously to unassign this, we would just simply, if we just grab that face and go back to the base color and click assign, we've essentially just swapped out those materials, and we're back to where we started. So that's a rough translation of the assign invisible faces.